and gentlemen, our second speaker today is Ward Rhodes. And Rhodes' background is he's a graduate of Maryland University with a degree in drawing and painting, and has spent most of his career working at Keystone College. He has been both the chair of the department as well as the regional chair of the Regional Center for 3D and Additive Manufacturing at Keystone. Let's give Ward a great big hand and let him start.
Thank you. Thank you very much. So this presentation is Lamps, Bones, and Volcanoes, oh my, and it's kind of designed, I thought I'd give you a little overview of what we do at the college relative to 3D printing and additive manufacturing, and then focus on 3 projects that are a little bit different, but and involve other areas of the college that might not be typically thought of as participants in this kind of technology. Okay, so this doesn't look like it has anything to do with 3D printing, and obviously doesn't. This is actually ancient technology, but one of the things I wanted to do to provide a little context is our Additive Manufacturing Center came out of the art department, which had a very long history of fine artwork. So largely, you know, out of a kind of a fine arts environment, this technology sprung. And we've had a long tradition of sculpture and metal casting at the college. So this is an example of an iron pour, which is something that we do every year. In fact, this weekend there's a big iron pour in Scranton centered around our iron program. This is an example of our long-term sculpture faculty member, Cliff Prokop, who's been at the college for many years. Really in the 1970s was considered, he emerged as as part of a little cohort of casting experts nationally, and these are a couple examples of his work. There's tons and tons of detail in this, and it's a bronze cast, so he uses a lot of wording, lettering, small imagery in these things, and I think when this technology first began to emerge, he saw this as a vehicle for his own work, to add another dimension to it. So I know this is annoying. So he was really our first player, and I remember, you know, 10 years ago as a faculty member in the art department, and when we got our first 3D printer, I looked at this thing, you know, with great skepticism, like, what did we just waste all this money on, you know? And but he started to delve into this technology, and it spread very organically, sort of through the art department. So that's just a little head model on a scanner. And these are some outputs. These are actually self-portraits of Cliff, so there you know what he looks like. And these are current works that he's done relative to once the 3D printing technology was incorporated into the work. So it allows him to use these same sort of forms, but forms within forms, very complex constructions artistically that he could not achieve in another way. So these are also bronze. And also, as part of the art department, students started to work on these projects. We started to delve into jewelry, which is a part of, it's always been a part of the sculpture program, but we started to use this technology to design jewelry and to fabricate things. And here's a little project that just happened. And I might add that most of these projects involve a faculty member and students. So this is a jewelry design that's a 3D printed ring for a commercial client. And that's actually prepared to make a cast. This is the rough cast in white gold. And this is the ring on someone's finger with a diamond set. So from start to finish, that project. And these are a couple of examples of student work where a student's using 3D printing to make things that are expressive, but all these little elements, and this has some elements of mixed media in it, but these little figures, and these are all very sort of personal self-expressions by this student. There's a couple examples here. This one, that's actually, the base is a map of Texas, and this is sort of an autobiographical piece about an injury he suffered in the military. And this is another example of that, incorporating that little wheelchair is 3D printed, and then he uses found objects to supplement. So I think one of the things that's unique about Keystone is that we can, because of the sculpture facility, we can tie these casting situations directly to the 3D printed objects. So we print in plastics largely, but we're able to cast in bronze, aluminum, precious metals, ceramic, porcelain, glass, plaster. And so our students can go from, the 3D printing to a finished object in sort of one setting without outsourcing. So a few years ago, we expanded upon what we had one printer for 10 years, and it started to be used fairly regularly by other parts of the college. And in thinking a little more broadly about this technology, we started to partner up with a few people, and we collaborated on a day very much like this one, a summit, kind of a symposium at the college. And we had a great turnout. You can see some of the partners that were involved in this project. And this is a shot of the conference itself. One of the keynotes was John Lash. He runs the Digital Atelier in New Jersey, which is a very high-end production house for artists, notable artists all over the world that work with foundries, and he's engaging all this technology. So this is an example of a very simple project that involves working with a manufacturing client. So this is, there's a small firm in the Mid-Valley that makes lamps, and they make these on thousands and thousands for hotel chains, for conference centers, and so forth. And they have a production facility in the Midwest that makes all the bases out of ceramic. They're mold-made ceramic pieces. So we started to work with them, and one of the problems they experienced was it took hours and hours and hours for one of their clay artists to manufacture a prototype. And if the client said, well, I really like that design, but I want to have a band around it or another sort of design, they'd have to make a whole new one. So from a simple sketch like this, we've been able to create a digital file. And there's the prototype of that actual lamp base. And these have gone from the prototypes that we've been making to, and we tried them in several materials. Here's one in red made with a different printer, and the surface is a little rough. To this, which is on the left side is the finished 3D model, and on the right you'll see the top of that form on the right is a 3D model, and the form on the left is the actual ceramic lamp base that the company has made. So they were able to make a production mold from our prints, and then ceramic, using ceramic, make thousands and thousands of those lamp bases, and they're out there in the world being sold. So now this is another little project that's kind of interesting. We have, as part of the college, we've got a forensic biology program and a rather robust criminal justice program. And one of the hallmarks of the forensic biology program is that when in this whole region, whenever a cadaver is discovered, our department gets called and our team goes out and helps examine the sites. And so our students are really involved in this field work. So these are actual bone fragments from crime scenes, these couple of pieces here. And one of the things our faculty wanted to do was to be able to replicate these fragments and then put them back in the ground and allow subsequent students to unearth them in a similar fashion. So really replicating that actual crime scene somewhere on the campus. And these bones are very, very fragile, so you can't rebury them. So we're trying to replicate these bones for the science department. And you can see the detail on some of these things. They're very hard to replicate. But there's a scan. That's a femur from one of these crime scenes. So that's actually the digital file. And we've been able to produce some bones. There's a skull plate here from that one that was upside down I showed you. And there's a couple of skulls. These are just prototypes. And then this third project I think is really interesting. And you really wouldn't sort of tie these two things together very, very often. But this is our, one of our technicians in our lab, and he's working on a geology model on the screen. And this project was presented by one of our geologists at a conference in Dublin, Ireland earlier this year. And it's called the Volcano Terrain Project. And it has to do with communicating volcanic hazards to populations that in villages surrounding volcanic eruptive areas. And the VMSG, there's a, this is part of a society. This is the definition of the VMSG. It's the Volcanic and Magmatic Studies Group. And they're part of a larger organization in Great Britain, in the UK, and Ireland. And so Ian, who's our geologist, is a volcanologist. So what Ian has done is he's taken a look at these hazard maps, and this is the core principle behind this research. Most people lack experience reading these maps, and these maps aren't readily available to populations living near volcanoes. And three-dimensional models help convey the same information in a much more tactile and tangible way. So the project basically is that we made 3D models of the terrain surrounding these various areas. And this happens to be a school in Costa Rica, a very rural school. And from the 3D models, plaster casts were made that each individual student could take home with them. So on these, they were taught how to plot the hazards and the distances, the radius around the volcano, and they could calculate the time it would take for the lava to reach various areas. And the children themselves then communicated this information to their families. So that's a much more direct way of conveying the information rather than a scholar trying to, teach a village about these dangers. So this is how the data was acquired. These are USGS survey maps, kind of readily available for geologists. And a target area. And this happens to be San Vicente, which is I think it's Costa Rica, this particular volcano. This is what a DEM file is. And then these files are converted to 3D files. So there's what it looks like as it's converted. And this is what we did with it. So there's the top topography of that small site area. And that's what the back looks like. And if you coat the back of these with a little bit of Vaseline and you pour plaster into them, you can replicate them, hundreds of times. So, and they're very inexpensive and easily transportable to other countries. You put them in your suitcase. So there's what they look like printed. And here's what the students do with this. So they add in, those are the possible lava flows from that particular volcano. And then circles would be drawn around it based on time. And, from the US that you might relate to a little better. Mount Hood. So that is the end goal, and he's done this in several countries and in a number of villages, and we've actually been able to share this with other geologists so that it's sort of spread organically through that community, and it's being utilized in several places in South America. So this is just to sort of flesh this out a little more. We have similar technologies to what a lot of people have talked about already. A number of printers, a number of scanners, we've got some cutters, and we have a small staff of dedicated employees. And our center director, Jim Harmon, is in the back of the room, and he's well versed in any technical questions you might have relative to what our center's capabilities are. But we are interested in the same sorts of things many people are. Partnerships with industry, that's why I showed you that manufacturing project. We definitely have an educational mission which extends both upward into the workforce and downward into high schools and middle schools, and educating our own students. And we anyone who's interested in this technology can stop by the center. They can see our machines. We can do design consults with someone who has a particular design issue or a problem. If you have an idea and you want to see it fleshed out, we'll work with you in that. If you had a file and you just wanted it printed, we could do that for you. This is our next event at the college. It's October 6th is actually the unveiling of our center, and it'll be a half-day symposium much like this one, and we've got a couple of great keynote speakers lined up, so just mark your calendars, and we'll make sure everyone that was enrolled here today gets an invitation. So, and I wanted to leave a little room for questions. So there's Jim's contact information if you'd like to reach out to the center. Thank you very much. I'll take questions if you have them. Yes?
What is the process and software that you're using to convert the DIM files?
That was Accutrans 3D, which I actually don't know very much about. Ian actually used that. I know that it's easy to use. And Shapeways uses it. So there you go. Yeah. Anyone else? Well, thank you very much.
Thank you very much.
Yeah.